thank you to everyone for attending this session. It's great to see so many of you with us, and I really appreciate the time that you're spending with us on this today. So in this session, what I'm going to do is I'm going to show you some of the changes that we've made to Serpac in the 2026 release of Serpac, to streamline the workflows within Serpac, particularly around the mine design and engineering workflows. So let's get started with that. I'm going to take you through 3 different sections here. I'm going to take you through one of them, which is working with block models, the block model converter, some of the best practice, what we should be doing with those block models. I'm going to take you through some of the user interface changes that have come in Serpac in the 2026 release and that are going to continue to come over the future releases. And I'm then going to give you a bit of a view to the future with custom panels and what you can do with custom panels and scripts to improve your pit design workflows. So let's start with our block model, okay, and our block model conversion. So working with block models is a key aspect of mine planning and a key aspect of design within Serpac. You need to be able to bring your data from wherever it's generated. And typically resource models are built in a number of different packages, not always in Serpac, sometimes in competitor formats as well. And so we need to be able to bring those competitor formats into Serpac and to work with them. Now, Serpac has always had and continues to have a very strong set of tools for how we work with our data coming from competitor formats. We've got our plugin module that allows us to drag and drop a wide range of different formats into Serpac and to work with it directly. That still works for block models today. So if you want to drag and drop in a data mine model or a Vulkan model or a micromine model or mine site model, then you can do so and it will come straight into Serpac and you can start working with it. Okay? But it will remain within that format, okay? Even if you use a FBM model type to try and convert it, it's still under the hood a competitor format that's there. And that leads to some problems. Okay? By having this competitor format, we end up with a very large block model, often many gigabytes of block model, that we have to try and work with within Serpac, and it's inefficient. It's slow, it's difficult to display, it's difficult to report. We don't have a full suite of Serpac functionality that we can use over the top of it. So our recommendation in this space is normally to convert your block model, to change it from whatever format it's currently in into a Serpac MDL format. Now, MDL formats are very nice. They allow us to use advanced blocking tools such as super blocking and dynamic sub-blocking, which means that we only create the small blocks where we need them and we combine them back into larger blocks where we don't need that level of precision. Okay? But that is still wrought with difficulty because if we want to take a model from a competitor format and bring it into an MDL format, then we need to be able to make sure we're not losing any precision. Okay? I don't want to join blocks together and add unnecessary dilution around narrow veins. I don't want to change the resource model that I was given. I want to have as close a reconciliation between my 2 formats as possible. And that's where the conversion steps take place to allow us to do things. Okay. The reason for the difficulty here is because of the subblock schemas that we use. So within Serpac, we use a subblock schema which is called an octree subblock schema. Okay? It means that you take your parent block size, let's say 10 meters, and when we create a subblock, that subblock can't be any size. It has to be an even subdivision of the parent block size. That means if we start with a 10 meters block size, we can divide it into a 5 meter. We can divide that into a 2.5 meter. We can divide that into a 1.25 meter. We can divide that into a 0.675 meter, and so on and so forth. Okay, but we can't turn it into a 1 meter subblock or turn it into a ½ meter subblock. Okay, the parent block size doesn't correlate to that. Okay, and it doesn't allow us to do it. Okay? But often that's what you get. You get a block model from a competitor format, and that block model from a competitor format, excuse me on that one, that block model from a competitor format will have inside it a range of different block sizes. So how do we work with them? Well, in the past, the way that we would do that and our recommended best practice for it was to export at that minimum block size, to build a brand new MDL model at that minimum block size and with a suitable parent block size schema, and then to import the data back in. Now that works pretty well. There are some difficulties with it, especially if you have a lot of attributes. because you have to export everything. It can create a very large file to begin with, and it's quite an onerous process to go through. But you can script it and you can make that work pretty effectively. But we shouldn't have to do that, and we don't want to do that. What we want to do is to work within the tools that exist within the software itself. So let me give you an overview of what that looks like. So before, it would take a long and painful process of that export-import routine. If you get it wrong, then you end up combining blocks that you don't want to combine, and that leads to a poor reconciliation between the models and effectively a loss of precision. Okay? The size of the models and the number of attributes means that when you use the old block model converters inside of Serpac, you could often run out of memory. The reason for that was because it would load everything into memory in one go, then try and reblock all of those attributes at the same time. And by doing that, you'd take what was already quite a large model and you'd blow it up into something enormous, okay, which would inevitably overload the amount of memory you've got in your machine, and Serpac would either crash or it would take a very long time to complete. What we've done now, though, is we've changed the way that our reblocking tool works. We're using a new function called the User Defined Reblocking. Okay? This User Defined Reblocking has two major improvements over the previous revisions and the previous releases. The first one is the ability to use local disk caching. Okay? Local caching means that we can take that block model and instead of loading the whole thing into memory to process, we can break it out into attribute by attribute and store those on our local drive and then work one at a time. What that means is that we never load the whole model into our memory. We instead just load one attribute of the model into our memory. And by doing it one attribute at a time, we don't overload the memory and we can still do it very quickly, okay? Very quickly. We've also added in the ability to utilize the power of your graphics card, your GPU, okay? Previously, all processing took place on your CPU, okay? But by using your GPU, we were able to unlock some of that power of the graphics card to process it even faster than we could before. This is only compatible with NVIDIA cards, I'm afraid. So if you're using an Intel-based card or some other graphical processing unit, it won't work. But if you're using a NVIDIA card that has CUDA technology, this will do it even faster than what you've been able to do it before. And it means that we can take enormous models and convert them down into MDL files, which are very efficient and very quick to use in a matter of minutes. So let's take a look and show you what that looks like. So we're going to go here and we're going to activate the user-defined reblocking. That's what we have here. We're going to go and find our block model that we want to use. Now, the import block model is we support a number of different formats here. So we support datamine format, we support Vulkan format, we can take them from CSVs as well, we can take them from Surpac format, and there's a couple of others that aren't listed here that will work as well. Okay? And once we open that model, we can then choose our output model. In this case, I want to output it to an MDL, but there are other options if you want to go the other way. We can then, within here, look at our different block sizes. So we can choose our user block size, what that smallest block size is going to be. We can choose our extents, and it means we can expand or contract our block model at this point in time as well. And we can choose how we're going to work with our different attributes. Do we want all of them? Do we just want some of them? How are we going to calculate for blocks that are added together? Okay, if they are added together, we can use an average or an aggregate method. And if they're a non-real or a non-float value, we can also use highest frequency or a multi-fractional approach to it instead. As you change your block size, you'll see here it telling you what your different block count's going to be, so you know roughly what you're going to create. And if you go into here, you can choose that calculation method. There are some other additional flavors here and options for how to calculate that value. It's well documented within the help file. So the real changes here are these three things down here. So there are basically three different options. The first option will be to export the attributes to the disk cache. Okay? This is what I was saying about not loading the whole model at once, doing it one attribute at a time. Okay? It's a little bit slower, okay? But it is dramatically more stable, okay? And it means that you won't get those out of memory errors that we've seen in the past performing reblocking. Okay? The second option is to enable graphical acceleration. That's going to use your GPU instead of your CPU, and it results in a much quicker processing time. And the third option is the multi-thread attribute processing. What that does is it loads the entire model into memory in one go and tries to process it all at once. That option is the fastest, but it's also the least stable because it's going to load the entire model into memory, and it's then going to try and create copies of that model for each attribute. And in doing so, it's going to create a very large amount of memory utilization. If you've got a lot of memory, or if you have a small model, it'll work, and it's the fastest possible route, especially if you turn on the graphical acceleration as well. But if you've got a large model, that option isn't going to work for you. If you do enable this top option, that bottom option will automatically be disabled. You don't run them both at the same time. It's either run it one attribute at a time through the disk cache, or load them all into memory at one go. So if you check this, you'll see this grey out in just a second. So in this case, I'm going to use the disk caching just to show you what it looks like. And I'm going to enable the graphics acceleration. And when I do that, what it's going to do is it's going to build a folder to cache the data, highly compressed folder, okay? And it's then going to go off and utilize, because I've used the graphics acceleration, my NVIDIA graphics card to do the processing. Because I already had a disk cache, I'm going to tell it to overwrite it. And the message window will update you on how long it's taking to process. You'll see here that the writing times and the reading times for each of these attributes are fractions of a second for this particular model, okay? And even on the very large models that I've used, it's a matter of seconds to do that writing. The reblocking and the recombination does take a little bit longer though. So on this particular model, it's extremely fast, okay? And once it's generated that model, it will save it in your working directory or wherever you've told it to save it, and you can then work with that model as you see fit. In this case, I'm just going to put on the constraint of that model. I'm going to display that model, and we're going to take a look at what it looks like and what we've done. So give it a second to display. There we go, models come up, and that's our reblock model with all of those blocks storing the data at the resolution of the competitor model. You've also got some new functionality in the layer menu there. So you see I can turn off the faces or the edges of the blocks just to make it a little bit nicer. And when we look into the block, we'll see here the sizing of that block model. And we'll see the number of blocks and the storage efficiency. Keep in mind the storage efficiency here is how much it's super blocking those blocks back together. This is part of the technology of Surpac MDL. That's why we want to use it. It's much more efficient. Even with very large numbers of blocks, it's much more efficient when we turn on that storage efficiency and when we work with it. And we can't get that with competitive formats. We can't get that with FBM formats. But that's why we're doing it. So that's our new reblocking tool. We would very much like for you to utilize it and to provide us feedback on what you like about it, what you don't like about it, what you'd like us to change in it. Okay, we'd be happy to look into that and see how we can change that and move it along for you and make it a better function. Okay. Moving along, we'll go to the next section here, which is around streamlining our workflows by looking at the way that we display our data and the way that we handle that. Okay. One of the things that you're going to see in Serpac 2026 throughout the entire 2026 release cycle and into the 27X release cycle is a focus on streamlining workflows. Okay. We want to reduce the number of clicks that you have. We want to make it easier to get hold of your data, easier to show your data, easier to work with that data. Okay, so you're going to see a lot of UI refreshes coming along. We've started with the block model coloring and the Drillhole Display functions because they're the most commonly used functions in Serpac. Okay, and so they're naturally our starting point. But what we're trying to do here is to remove the number of pop-up forms that you get. Okay. So if we take a look at, say, displaying our drill holes, for instance, I've always been able to connect the database in, I've been able to hit the display function, I've been able to set up the parameters of display, and from that we get our drill holes displaying for us in our graphics. Okay. Works fine, it's always worked pretty well, okay, doing that. I can add in labels, I can add in charts and graphs and that kind of thing, okay. But the problem is if I want to make a change to it, if I've selected the wrong parameter, or if I just want to add extra parameter, another label, a different coloring, that kind of thing, I have to rerun the function and show the form again. complete it, hit OK, go again. Okay. Anytime I want to change it, I have to re-find that form and re-have it show up for me. And that slows us down. So we don't want to reload the form constantly. We want to have something that persists for as long as you're displaying that data type so that you can just quickly and easily make changes. That's what we're doing through the use of panels, okay, to allow us to change those colors and displays dynamically and to have it persist across multiple screens and multiple viewports. Okay? So the benefit of it is that you should be able to run those functions faster than you have before. It should be more interactive. It should make it faster to display it, and it means that you'll be able to see the update immediately. Okay? What we're also planning on doing is to add more additional functionality into those panels. So it doesn't just give you one function in that side panel, but we start to provide additional functionality across the top. And you'll see that in a second in the video, what we're doing there and how it works. So this is a long-standing process. We're going to update a lot of the user interface in Serpac over the next year. Okay, and this is our starting point, but you'll start to see more and more of this coming in. Okay, so we're moving some of our key functionality. So in this case, I'm going to go and grab a Drillhole database. I'm going to connect it in. In previous releases of Surpac, we enabled now the ability to have multiple databases. So if you've got multiple ones open, you'll see them in the side panel. And we've got some quick right-click functions to hide and display. When I choose to display it and display my Drillhole, you'll see this side panel appears. And within that side panel, I can now set up how I want to color things. But this is the same as it's always been. I can sit there and color it by rock code, give a cylinder style that I want to have, and there's my data. But instead of closing the panel persists. So if I got it wrong, I put rock code when I meant to put rock type. Okay, let's add in rock type and run it again. Okay, it'll show me what we've got. Okay, let's change the radius and reapply it. Okay, there we go, quick change. No need to pop up the form repeatedly. It persists over here and I can work with it. The other thing that we're adding in here is the ability to store those settings so that you can reuse them and so you can share them with other users. So we've instigated this option here called a project name, okay, for our display properties. And within that, you will store all of the settings that you have in this display so that you can record that as you need to. So if I go and grab that display and I hit refresh on here, it's going to redisplay all of my data. I'm going to apply it, and it will then utilize the display that has been stored in that particular project file. The project file is an XML file, text-based. So if you want to view it and look into it, you can edit it from text editor. I wouldn't recommend it, but it's possible. Or instead, what you can do is just load it from here, make any changes you want, and save it using this output here. Okay? And then that file can be saved with the database and shared with different users. Okay. Everything persists, so labels persist across it. We're able to use those. We're able to see all of that data coming through for us in one hit, in one go. Okay. You'll also notice that we've got some core functionality across the top here. These are our commonly used Drillhole functions, such as showing the display style. So I can click on that, show my styles data, edit that style data, and view it. Okay. We've also got in here constraints. So the constraint function was updated a few releases ago in Serpac, but I wanted to take this opportunity just to refresh you on what we can do there. So we've got the ability within this constraint function to constrain based on any of the Drillhole metadata or Drillhole attributes. So if I want to say, I don't want to see any of my trenches, I just want to see my RC holes, my diamond drilling, then I can add that in here, use it as a constraint, and it'll apply. Okay. You can also build complex constraints here. So it means that if I want to manually remove a hole, I can use this option here to manually remove hole. And then I can select the hole that I want to remove from my constraint, and it will remove it from the constraint. Doesn't remove it from the database, it's still there, but it takes it away from my view and from my constraint. And that constraint can be saved, and we can utilize it downstream if we want it. You can also clear the constraints, either remove the last one or remove all constraints. You can do it one by one or all at once, your choice. Okay. And that allows us to show our data in different ways. So constraining based on an attribute in one of my tables is easy. What I want to show you now is something a bit more complicated. It's one of the spatial constraints that we added in. So spatial constraints allows us to utilize any of the different options that you've got here in that constraint table dropdown. So it means I can constrain by a surface, I can constrain by a solid, I can constrain by a segment or a string if I wish to as well. Okay? Or I can combine these, save it into a constraint file, and use that constraint file as an additional constraint. Exactly the same way that we always have done with our block model constraints. And so it means we can build some very complex constraints out of it. This one's going to be a simple one. I'm basically going to constrain all the drilling within the silhouette of my pit surface. I'm going to go and grab that pit. I'm going to add it in, and I'm going to use the option to keep the drill holes partially in the constraint. Okay? What partially in the constraint means is that if any part of that drill hole enters the silhouette of this surface, then I'm going to retain that drill hole and use it. And you'll see that for these drill holes up here in the north, they're not intersecting the surface, but the bottom of it does intersect the silhouette of the surface. Okay? The boundary of that surface projected up and down. So I can use that to show my data and to build more advanced constraints than ever before. The next one I wanted to show you was the panel for block model coloring. Okay? So the panel for block model coloring, you'll see as of previous releases, you can load multiple block models now into Serpac. And if we right click it, we're going to bring up some of the most commonly used functions. So we've got here some visibility, some bases, some edges. We're looking to improve and add to this, but this is what we've got so far on it. Okay? So if I choose, I can turn off the block edges quickly from here. I can show the block edges from here as well. Right? I can show all of my data. I can hide the block model dynamically from here and re-show it. And you can do that on a block model by block model basis. If I choose to color the block model, then I'm going to get the block model color panel. And that panel is going to persist for me on the right-hand side here to allow me to make those changes as I see fit. So if I want to scan it and display grade ranges by gold, I can do that. If I want to edit the grade range, I can do that. If I want to change it to a different attribute, I just choose a different attribute. Again, reapply the coloring that I want to use from that and see the results straight away. So the aim here is just to make it faster than having those forms popping up all the time. The last thing I wanted to show you on this in Surpac 2026, before I get onto some of the custom design tools, is to show you what's happened with the layer panel. So the layer panel here has been upgraded with a lot more detail about what you have open in your active layer from your string or DTM or SDM file. Okay. So in this case, when you dig into that layer, it's going to show you the objects of the layer. You can see all those coming through here. We can also see from here the try object and a try isolation. So it means that I can dig into it in the layer manager and see its color. I can use the most commonly selected functions in here, such as zooming it, hiding it, validating it, renumbering it, or deleting it. And I can do all of that directly from that layer manager setup rather than having to do it from the functions. Same thing for strings and segments. I can show all of my strings. I can see the color for each of those strings and segments. I can right click on them as well and do things like selecting it, hiding it, showing it, renumbering it, or deleting it. So all of that functions there. Again, we're looking to improve the right click menus, but this is what we've got for the moment. If you've got something you'd really like us to have, please let us know. We'll be happy to write it in. The other option that we've got here as well is if I open a large number of string files into this, we've got the ability to search and to filter our layer manager. And then from there, we can change the display of it. We've also got the ability to reorder it so that we can order it by alphabetical on the layer manager there. So these are relatively small things, but they're quality of life, sorry. It means that we should be faster and better with our processes by doing it. Okay? So that's the main aim of it. But if there are other parts of your workflow that you would like us to look at and try and improve and speed up, please let us know. We'll be happy to take a look at it with you. Okay. On to the next one. So the next thing that I wanted to show you, and the last item on my presentation today, is to look at the custom panels. So we've always been able to use scripts to customize workflows within Serpac. Okay. We're able to daisy chain different functions together. We're able to create brand new functions if we want to. And in recent releases, we've also added in the ability to do Python scripting and to utilize that. So what I wanted to show you here was a bit of a view to the future, because one of the things we want to do across the 26 release cycle and the 27 release cycle is to really improve the workflows of people. And one of the areas that we want to look to improve is in the pit design. Okay? So I'm going to show you a little bit about what we've done there. This is a prototype, so it's not available for you to use at the moment. But if it is something that interests you, please let us know. I'll be happy to share any of the scripts we've got. I'll be happy to give you a chance to play around with it once we've tidied it up a little bit. And if it looks like we're going in the right direction, then please let us know, because we'd like to integrate this into the product as an out-of-the-box functionality. So when we create pit designs in Serpac, it requires a number of different functions to create that design. And those functions are stored in different menus, in different forms, in different toolbars, so that you can access the function that you need and work with it. It inevitably means a lot of clicking, a lot of searching around for the function you need. And it's a bit of a slow process, to be honest, which is something that we've been looking to try and improve for a while. So what we've done is built a customization. And that customization allows us to store a variety of our pit design functions all together in one of these side panels, and to augment that standard functionality with some custom functionality. So to give you an example of that, if we want to create our pit design, the basic way of doing it is that we load our pit shell, we section our pit shell onto a plane that we want to design on, we digitize around that pit shell. Once we've created that toe line, we then need to adjust it and smooth it to get rid of any sharp angles to make it look nice. Then we need to put in place our ramp entry. That means breaking the line, creating the correct ramp width, creating the points, making sure nothing's in the way. And then once we've done that, creating our ramp, setting the points, making sure that we've set our face angle that we want to use for the projection. And then we're able to project by bench height and create our next crest. That's a lot of clicking and a lot of functions to get one extra line out and a ramp. So we want to be able to shortcut that and make it faster than we've been able to do it in the past. So the way we do that is that we've added a load of manual functions to automatic functions, and scripts to be able to get us around that in this custom panel. The other thing then is, once you've created that crest, well, then you need to expand it by a berm width. You may need to adjust that berm to take in the extra material of the pit shell. Okay, and then once you've done that, you have to make sure that your ramp points haven't been lost, and you then have to project up to your next crest. It's a bit of an inefficient process, and it's an area of focus for us to try and improve over the 26 release cycle. Okay? So at the moment, what we've done is we've put together this set of tools to try and streamline that and to give a bit of an idea and a prototype for what it will look like. So let me walk you through some of that. So what we've developed here is a side panel, which is called the Surface Design side panel. And within that, we've got the ability to resize it, to undock it, to move it to different windows, to work in a multi-window environment if we want to, if you've got multiple screens, to be able to resize it, to be able to change what it is. This is why we've created it as a panel. But also I want it to persist so that it's there constantly for us and able to work. We've also created the concept here of a pit design project. So within that pit design project, I'm going to be able to create a name, and that pit design project is going to store some of my parameters that I want to use later. The idea behind this is that we should be able to pick a design up and put it down without having to re-enter all of the parameters that we need for it. We should be able to load it and just start working and go again. Okay? So by having this project file, we can store all of that background metadata and utilize it. Things like the angles, like the heights, the widths, the ramp widths, the bench shell that we're working on, the optimization shell that we're working on, the elevation that we're working on, that kind of information. Okay. So I'm going to put that in. I'm going to select my optimization shell, and I'm going to tell it that we're starting at 20 meters RL. For this design, everything's centered around 0. Okay. So I'm going to choose that, make sure it's all turned on, and hit apply. And what it will do is the function will go off and automatically section that picture and set me to the correct plane to work. Okay? Now what I'm going to do is I'm going to use the auto design tools to create my first toe. Now you don't need to worry about snapping to things too much because we're going to smooth all of this data anyway. The more points that you insert, the more it's going to control the shape in that area. The less points you insert, the more it's given freedom to smooth between them. Okay? And by doing that, we then apply our smoothing algorithm, and away it goes. So you simply digitize it, press escape, the toe will be smoothed, any sharp corners will be removed based on the corner tolerance that we specify here, and it'll generate me the starting toe. Okay? Again, if I didn't like the way that looked, all I needed to do was to create a couple of extra points in the corner, and that would have sucked us in closer to this corner. Okay? Now that we have this shape and we're ready to go, we need to position where the ramp's going to be. So the next option is to pick a point, and it will give us a view of the template. So this width is based on the ramp width that we specify here. It's going to detect that point where it needs to project to be on the outside. It's going to then detect where it needs to bring the shape back to intersect. Okay. And it's going to then detect that intersects for me. So I can choose it there, or I can move it wherever I want it to be. I'm going to have it here for this example. And when I hit escape, it automatically inserts that shape into my toe. So we'll break the toe, add the points in, close the toe, and make sure that it's compliant for use in my design downstream. Okay. I'll then get my standard ramp definition menu pop up. It'll be pre-populated with information from the panel. And at that point, I'm ready to get started. So if I hit apply on this, it will automatically go off and generate the ramp and generate the crest and toe of the next bench. Okay? Toe of the next bench, crest of this bench. Okay? So it goes off and generates that for me. Within this sidebar, you can apply smoothing at any time, but it will happen automatically anyway if you've got that box checked. You can also use it in the old-fashioned mode. So if you want to just expand by a bench height and a berm width the way that we do normally, then simply turn off that auto berm addition and use these functions independently, and they'll go off and do what we need to. But if we want to do it in an easy fashion, we've got this ability to turn on the auto berm addition. And as soon as we do that, it'll generate the whole bench in one go. So let's go up 2 benches at a time. We'll turn on the auto berm addition and we'll tell it to expand. And it will go off and generate those 2 benches for me. Now that I've generated those 2 benches, I now need to adjust out this toe line. So I need to adjust the toe to take in this expansion of the pit shell. And I do that by using a function here called berm expansion. You could do it the old-fashioned way, break the line, reactivate it, digitize around the edge, break the line here as well, delete the points in between, rejoin it, close the segment, smooth it to make sure it's a nice shape, and away you go. But it's a lot of clicks and a lot of functions for what we should be able to do as one. So what we did here was create this custom script, which will allow us to effectively digitize over. As long as I cross the line, it will detect its intersect, put in a few points down the bottom here, and then drag it up and intersect again. Okay. The smoothing will be applied automatically. The line will be broken. The line will be incorporated into my new line. Okay. If I like it, I can just go as it is. If I don't like it, I can still move the points and edit the points within this. Okay. I won't lose my ramp points either, because the ramp points are assigned based on their coordinates and not based on a point order like it typically is in the Serpac tools. So by doing this, I've streamlined that process of not losing ramps as often as we have done in the past. Okay. And that's why you see this ramp point coordinates being published down the bottom here, just letting us know where we are for each point. So now what I'm going to do is I'm going to jump up by a single bench. So let's do that. And it will project me up by 1 bench. I'm going to need to expand the toe again here. So I'm going to go up and use my berm expansion method. I'm going to tell it where to start from. I'm going to digitize in a few points. Okay. More points will control the shape. Less points allows it to smooth as it needs to. Okay. It's up to you to decide how much you want it to honor certain shapes. And then I can go off and make sure it crosses that toe line twice. Okay. If I hit escape, it'll merge that in. I'll get my new option. So let's project up again, project up again. And now I think I'm going to have a problem on the next projection. So I think that we're going to have some issue with this sharp angle. It's going to give me a weird kink in the ramp, and I don't want that. So what I'm going to do now is I'm going to use my standard point editing tools and segment editing tools. And by doing that, I can come in and I can delete this point. It just so happens to be the first point, so it's opened a segment. That's bad luck, but it happens sometimes. And in the older tools, if you'd have done that, you'd have broken the ramp points at this stage. So if you break the ramp points, then you have to reassign the ramp points before you can get going again. Not within this tool. It remembers the ramp points, so you're good to go. So I could move the points, I could delete them. There's lots of different ways of doing this. I could redigitize if I want to. I could even use the burn expansion to just digitize something across here that might be a bit smoother and cleaner to do this. But for this example, I'm just going to delete things and rejoin it, just to show you the point delete and the join tools work as expected. So at that point, I've closed the segment and I'm ready to expand the bench height back up. And off the way it goes. So now let's go up a large number. Let's go for 9 benches. Okay. It's going to generate 9 benches up and beyond. Okay. Ideally, I should be checking each bench. I should be expanding the berms on each one correctly, but this is a preliminary example. I'm just going to show you what it looks like quickly. So we've gone off and generated that. It's called it through. Pretty neat and tidy. Looks as we expect it to look. So now what I can do is triangulate that surface, which I'm going to do here. And I can display the triangle faces again. We disable them when we're clipping the pit shell so they don't get in the way. And there you go. There's your design. There's your surface. And you can then use that to report tonnage and grades from the block model. You can merge it with topographies. You can use it for clipping, whatever you want to do with it. So the basic premise there is that we're trying to build a bit of a prototype for how we could streamline that workflow. These are some of the ideas that we have. If it looks like something you'd be interested in trying or giving us some advice about how you'd like your workflow to look, please let us know. We'll be happy to answer any questions, happy to work with you on it. Thanks very much.